Okay, in the last video in this little series of looking at injection quantity and what's going on with duration and start of injection, I looked at what might be possible, but what the advantages or disadvantages of that might be. Now, here I'm just going to look at what happens then if we actually make a calculation and we make some real changes. And I'm going to propose the same changes that if you look at the video that I made about duration, you will see the same sort of comments there, but in a slightly different format. And that again uses figures from the Seat Leon 1.9 EDC16 105 brake horsepower. Now this engine uses fairly small injectors, depending on how you want to define small, but smaller than more powerful engines. So if we look at 5,000 revs per minute, 60 milligrams per stroke injection quantity, duration 44 degrees, SOI 27 before top dead centre. Those figures are taken straight off of the files. So I haven't made them up, they're just straight from that file. Right, now let's make an assumption that we are flat out at that point. So in other words, let's make an assumption that the designers looked at this and they said, right, foot to the floorboards, maximum 60 milligrams, 44 degrees, is the amount of time it's going to take, 5,000 revs is the engine revs that you're going to get at that point. This is the best you're going to do. So in other words, you can't have any more fuel. Now, the thing is are you being limited because the designers just thought, no, we're not going to let you have any more? Or are you being limited because that's it? The injector can't give you any more fuel, so if the injector can't give you any fuel or more fuel, you can't really have any more, can you? And I don't mean in total, I mean in any given amount of time, because this is all about time. So okay, let's have a look at that for this amount of time. So let's say to ourselves, okay, we've got 44 degrees and 60 milligrams. So that means that we will end up with, if we divide the two, 44 divided by 60, 0.73, I'll ignore the rest, 0.73 degrees per milligrams of fuel. So I need 0.73 degrees to inject a milligram of fuel. Now, if I say to myself, this is the best, so in other words, I'll put it there, if this is the best, then what happens if I want to inject 65 milligrams? Well, I just times or multiply 65 by 0.73 is what I do. So I times 65 by 0.73 blah blah blah, and I end up with 47.67 degrees. So I've now got a duration of 47.67 degrees. What's that going to do to my start of injection and end of injection? Well, at 44 degrees, end of injection is minus 17 degrees. So I haven't really got room to play with here, have I? Because, and I guess the designers would have taken this into account with the files anyway, but I can't very well stick 3 degrees on the end of there. And I don't really have the option to do that anyway, because there are no maps which allow me to play with end of injection. So I can't stick 3 degrees on the end of there, so I've got no real choice. This is going to automatically advance the start of injection 3 degrees whether I want it to or not. So I might as well go and make an allowance for it so that it can start 3 degrees earlier, because I run the risk of it trying to do that regardless. It may not do it if there aren't any maps to allow it though, and there's always a problem with that. Some maps seem to allow modifications that seem to be outside the scope of the map and others don't. So you never know for sure until you try. But let's assume that we know we've got to go for an extra 3 degrees, so we advance start of injection 3 degrees. So now we've got then 5,000 revs, 65 milligrams. It's going to take us 47 degrees roughly. I've knocked the odd bit off the end, so it's going to take us roughly 47 degrees, and we need a start of injection time 30 degrees. So is this safe? That's what I've written there. Is that safe? Is that okay? Well, one of the clues is to go and look at the limiter, because if the limiter is set at 30, then you can usually safely say to yourself, well, I might get away with 30 because the limiter's set at 30. So that's your first clue anyway. As I've put here, the simple answer is it's probably not in terms of wrecking the engine, but it may well not be safe in terms of just ordinary everyday driving around, because it might be that if you constantly run around with this sort of change to your car, that 99 times out of 100 you'll be fine, but then one day you may be cruising on the motorway and just have the right air temperature, engine temperature, fuel temperature, and all sorts of other bits and bobs all ticking away at the same point, which just allow things to tip the edge of the balance and do some damage to the engine. And this does happen. People tune their engines, run around in them for ages and think, oh, this is great, and then suddenly, bang, something goes wrong. So it's worth bearing that in mind. Now, as I've said here, the original value is 44 degrees and 27 degrees SOI for 60 milligrams of fuel. That's fairly big duration and a fairly large advance. So if you go to 47 degrees duration and 30 degrees before top dead centre, as I've just said, you might be just on the edge of where you might put pressure on the cylinder head bolts and maybe the cylinder head gasket. Now at this point, it would be nice, wouldn't it, if you could watch these videos and get a magic answer. You know, this guy will tell me the answer to my problems, but there isn't an answer, because you will find someone on the internet who's perhaps done this and said it's great and I didn't have any problems, and you will probably not find someone who says, oh, I tried this and it blew the engine up, because they probably keep quiet. But the only way really to find out would be to make these changes and then don't go running around on the road. You go to a rolling road with these changes, and while you're there, because it's quite difficult to measure cylinder pressures, what you would have to do is measure all of the fueling that you could, all of the exhaust temperatures that you could manage, and the power outputs that you could get, and then you would check to see if there was any possible way that you were getting an improvement that A, you wanted, and B, was worthwhile. Because if the improvement you're getting is minuscule but you've increased the chances of damage in the engine, why bother? Unless of course you like rebuilding engines. So this particular engine and this particular ECU is not a good example in terms of, hey, look at this, I can go mad and make all these strange changes. There are other VAG engines where when you look at the files, they have got much more scope for changing the values. This is not a good example for that. But it doesn't matter, because the way you would go about it and the way you need to think it through is exactly the same, whichever file you're looking at. Don't forget, all of this information is about VAG diesels. It doesn't apply to some other manufacturers, because other manufacturers, A, they don't use PD injectors, or at least most of them don't, but also some different manufacturers calculate their maps in a slightly different way, so you can't make direct comparisons. I know people do sometimes, and some of them probably blow their engines up as a result of it. Right, I'll stop there and hope that that's given people a reasonable grasp. I apologise for mistakes, they're all mine. I've just made this up as I've gone along, so I just hope that I've kept as near to the correct information as I possibly can.